Okay, I am going to switch the screen. So if you need to write the problems down, write the problems down. I'll have them on the other screen. I'm going to work them out. So an important part of these directions is that your answer should be in simplest radical form. No decimals. This is the stuff I'm answering. So right now, you want to isolate x squared. You want to get x squared alone. Or sometimes it's like a whole parentheses in x squared. You want to do that before you square root. So when I look at this problem, I'm going to put a line where the equal is, and I'm going to cancel the 14. And now it's 2x squared equals 56. And then I'm going to divide by 2. And I get 28. Everybody give it 28. Correct. Right now you're doing this number one right here. It is different than what's on the board. Okay. So then I go to square root both sides. The square root of 28 is what? 5.2? I'm going to guess. I know the square root of 25. What's the square root of 25? 5. What's the square root of 36? 6. So the square root of 28 is somewhere near 5 and 6. Between 5 and 6, just a little higher than 5. It's probably 5.2. Did anybody put it in a calculator and get a decimal out? Your TI-36 calculator, if it's setting right, it's going to simplify the radical for you. Oh, good. 2.19, okay? But I'm not interested in seeing the decimal. The reason we don't want decimals a lot of times with radicals is because the decimal fills up the whole calculator screen. It actually goes on forever. It's called an irrational number. The decimal just goes on for eternity. It doesn't repeat. It's like pi. All of these square roots are like pi. They're irrational. So scientists, chemists, biologists, the pharmaceuticals, engineers, they don't want to write the decimal down because when you round it, you compromise it. It's not as perfect anymore. It's not as exact. So when they do their math and the software does the math, it keeps it in radical form. And that way the decimal isn't compromised. It stays perfect. All of the numbers are there, not just the 4 that you choose to write down. Okay? So here, No decimal. So we just need to simplify. And you use numbers that do square root. So when I think of the number 28, I think of 2 times 14. But not really. Who thinks of 2 and 14? Nobody. I think of 4 times 7. So I'm going to rewrite this as 4 times 7. Notice I put a plus or minus sign in. Let me take that 2 out of there. As soon as you square root, put a plus or minus sign in. Okay, so this is the same as the square root of 4 times the square root of 7. And we do know the square root of 4. The square root of 4 is 2. So the answer we're looking for is 2 square root 7. This is actually a bell work question. Okay, and I'm about to do 2 if you want to start 2 on your paper. Okay, so your calculator will do that for you. Your calculator pops out 2 square root 7. But I'm going to require you to show this work. You have to show how your calculator went from 28 to 2. You have to show that understanding. And that's because in college algebra, they don't let you use a calculator. So I'm going to let you use your calculator, and I'm going to deal with putting them away and taking them out. But you do have to show your work. Yes. What'd you get for number 2? What? Dang. Why not? You're a quick worker. Why didn't you do it yet? You have a question? What is your question with the math too? Did you have your hand up? Figured it out. All right, let's do number 2. All right, we have a fraction here in front. Yes, you can go, Lewis. I'm going to multiply both sides by 4 over 3 to cancel the fraction. I'll use the reciprocal. And now we got 40 over 3. Now that the x plus 1 squared is isolated, we will square root both sides. I'm going to use the plus or minus sign, 40 over 3. I don't like 40 over 3 under that radical bar, but it's a decimal. I'm going to leave it. I'm going to do one more thing, and then we're going to move on. I'm going to minus the 1, and it'll be negative 1 plus or minus this ugly fraction. And you can stop there. And the last question of bell work number 3 was, what do these solutions represent? These solutions are x-intercepts of a parabola. So please don't forget what we're doing here. We're still looking at graphs of parabolas. These are x-intercepts. The majority of parabolas found in nature, like our natural world, models parabolas and quadratics all over the place. And when it does, it's complicated. All right. When you drop a ball off a cliff, the time and distance models a quadratic, but it doesn't land exactly 5 feet. It lands 5.4239876491112, right? It's complicated. It's decimals. So this is a complicated decimal because it models something really in nature. Those even numbers that we get when we start out with graphing, that's not the real numbers that are often used. So unless you do significant figures, which we talk about next time. Okay, any questions on 1, 2, or 3? Okay, before we go over yesterday's problems, we're going to practice this more in case you need to go back and fix anything. So you are now going to do these problems on the board. Some of y'all might get to 4, and that's as much time that we have, right? Some of y'all are going to finish 7 and have time to spare. There's lots of different work pieces in the room. So work at your own pace. Your goal isn't to wait for someone to do on the board, copy down, and do work, get it done, right. Your goal is to try to figure some of these out. Okay? So if you're feeling like you don't know anything, take the next 15 minutes to figure out 1 and 2. If you're kind of in the middle, you need to get to 4. If you're working very quickly, what you need to do